In this video, I am going to show you the advantage of using Excel IFS function over nested if. The table in this worksheet shows the marks scored by students in various subjects. So this is the score, percentage score. So my objective is to give grading based on these conditions specified in this table. So first let us construct this grade formula using a nested if, which is very complex and difficult to understand. So I will construct the if condition. So if the score greater than or equal to 75%, then the grade is distinction. So this is the if condition. If the score is greater than 75%, it gives the grade distinction. Else we have another if mentioned in the if condition. So it becomes a nested if. So I'm closing the bracket also. So in the else part, if the score is greater than or equal to 65%, then the grade is first class. Now in the else condition of this, there is another if which becomes more complex and difficult to read. So I am going to close the bracket. And if the score is greater than or equal to 50%, then grade is pass. Else, when the remaining all conditions, that means if it is less than 50, it is fail. So this has become a very complex nested if formula. So this if is nested within this if, which in turn is nested within the first if condition. So such nested if conditions are very difficult to comprehend. So let us see the results by pressing enter. So 63% it is pass because 65% is first class. So I am going to copy this formula by double clicking this formula. So 78% is distinction, is correct. 39% is fail. So let us closely look at this formula. See how complex it is. So it is very difficult to understand the logic as well as to create this formula because there are nested ifs within the parent if. So there are two ifs within the parent if. So how to solve this problem? So solution is using an ifs function. So I'll construct the formula in column F using ifs. The same grading we will give using ifs function. So ifs function is straightforward. So we have to give first condition, that is score greater than or equal to 75% and the value is distinction. Then there is no else, comma, and next condition is again score greater than or equal to 65%. If the condition is true, the value is first class. Then the third condition, score is greater than or equal to 50%, the grade is pass. Now we will not specify any condition for fail. I'll close the bracket. So this is very easy to read. So if it is greater than 70%, distinction. If it is greater than or equal to 60%, first class. If it is greater than or equal to 50%, it is pass. So the ifs conditions are evaluated in order. That first it will execute this and see 63% is greater than 75%. No. So it will go to the next condition. So its score is greater than or equal to 65%. No. Then it goes to the next condition. The score is greater than or equal to 50%. Yes, 63% is greater than or equal to 50%. So it assumes the value pass, and so it will not check the remaining conditions. So that is how it works. So let us press enter. So it is a pass. But note that we haven't mentioned any condition for fail. If I copy this formula, let's see what happens. So it throws error when it evaluates marks less than 50%. So how to correct this? So I will edit this formula. So the easiest way is to give a default value. So how to give a default value for ifs? So we have only these conditions. If it doesn't satisfy these conditions, print the default grade. So how to specify the default grade? Just specify true. So instead of giving a condition, you just mention true and give the default value. So I'll give fail because the remaining condition is less than 50%. So in the place of condition, you have to specify true and the text to be printed if none of the specified conditions are satisfied. So you print fail. So only one condition is valid for this, which is less than 50%. So let's see how it works. So press enter and let's copy this formula. So now let's examine this. So 39%, it is not greater than or equal to 75%. It goes to the next. It checks this condition. 39% is not greater than or equal to 65%. So it goes to the next condition. 39% is not greater than or equal to 50%. So it goes to the default condition and prints fail. So that is how ifs work. Let's see another example of ifs function. In the previous example, we have used the same column in all the conditions. So in this example, we will use different column, different condition. My objective is to shortlist the rows in this sales data table based on this criteria. So region has to be East, or product has to be DEF, or quantity has to be greater than 800, or revenue has to be greater than 20,000. So if any of these conditions are satisfied, I will shortlist those rows. So I will type the ifs condition. So ifs, so region equal to East, then shortlisted for East. Product. Now I will add the default value, for which I will give the condition as true and value as not shortlisted. So A2 is equal to East. A2 means its region is equal to East. It will be printing shortlisted for East. Product is equal to DF, shortlisted for product. Quantity greater than 800, shortlisted for quantity. Revenue greater than 20,000, shortlisted for revenue. Default value, if none of the conditions are satisfied, then it will print not shortlisted. So let's press enter and see, and I'll copy this formula. So shortlisted for quantity, then shortlisted for East, that is region, not shortlisted because none of the conditions satisfied. So region is central, product is not DEF, it is ABC, quantity is less than 800, which is 700, revenue is less than 20,000. So it's printed not shortlisted. This is how the ifs function works. That's it for now. Thanks for watching this video. Please click on like button if you find the information I shared useful, and update comments. Also, please subscribe to my channel to get notified about new videos which I will post in future.